I'm back at work underneath the chassis. Just popped out the third multi-suction electrolytic. This is another one that tested bad. It's only 2 sections, a little stubby guy. So these are going pretty quick. I did blow out the fuse in my PR57. I just replaced it. So that's back in action for when we do a power up. Now there is another possibility. So I was thinking none of these caps tested like a dead short. So I'm a little suspicious that that's actually what it was. I hope that's what it is, but there's another possibility. I forgot. Something I normally do before I ever apply power to a set is there are caps on either side of the AC line going to the chassis. And they are they quite often bad. Here is one of them. It's a micromold looking cap. I think it's a paper cap inside of a Bakelite housing. Now if this was dead shorted and I applied full line, I would think it would have blown apart, and they didn't. But let's test them. Let's see. I think they're .01s. They're supposed to be what we call safety caps these days. These are not safety caps. Safety caps meaning they're rated for safe use across the AC line or from the AC line to ground. One other thing before I forget is, I think I mentioned earlier, I had some bonus items to offer the owner of this set. Well, here is the original instructional owner's manual. We'll look at that another time. I don't want to take it out of plastic right now. And I also have an original service manual. This has been scanned, is available online, and it's been reprinted in the riders, but I think it's always nice to have an original, so I'm going to keep both of these off the workbench so they don't get ruined. Yeah, so let's pop out both of these guys and test them, and we'll get back to doing this. Alright, got one of them hooked up. Now, with modern ones, they typically be rated for 220 or 440 volts AC, and then the DC rating will be 1,000 volts or more. Typically the AC rating is far less than the DC rating. But anyway, let's... well, that ain't good. Regardless AC or DC, it should not be shorted at only 100 volts. So that might be what killed my meter. And maybe it didn't explode because the fuse popped in my tester. So the hell of it, I'll try measuring the capacitance. And no, it's not. It's not giving us anything. Let's check the other one. Not as bad when it's flashing. That means it's charging and discharging. But yeah, no, that's not good. That's not good. So they're both bad. I wish I had thought of that, because maybe we could have gotten. Now those electrolytics did test terrible, but we might have been able to eke something out of the set. All right, we'll never know now. All right, 3 out of 5 electrolytics have been rebuilt. Replaced the chewed up wire. We clipped out the 2 caps across the AC line. Put all the tubes back in, weak and good. Let's resume where we left off. That's 60 volts AC into the set. Maybe a little more, maybe more like 70. And of course, the new caps don't have to reform, so I don't need to go quite so slow. Anything we want to avoid is we don't want to see that current. Remember, for normal operation, it should be a bit off the scale. I'm on the 1.5 amp scale. So it draws a little less than 2 amps. So, 80 volts. just going to go for broke. Got about 110 going in now. Current draw is a bit under 1.5. Holding steady. Alright. Let's get our old fluorescent bulb. How about that? Hey, we have glowage. Not seeing anything on the CRT though. Not hearing any crackle out of the speaker either, but well, we certainly have had our share of bad high voltage rectifiers. Now I did test this one. I tested weak, but it's not dead. I see the filament on it glowing now. Well, we get our high voltage probe and let's see what's going on. Alrighty. The doorknob high voltage filter cap is really easy to get at in these sets, so we can just plunge this right down in there. And almost 7,000 volts. Awesome. That should be plenty. See if my little test CRT filament is glowing. Yep. Alright, what's going on here? Could just be the CRT is biased so far off that it's just not going to get an image. But hey, this is good. You know, I mean, just a little bit of work, and we can safely, well, we can turn the set on, and we seem to be getting some high voltage. Alright, so I'm going to continue work on it, and what should I do? Because I can try to track down voltages on the CRT, and see if maybe it's just biased too far off and it's killing electron flow. Well, I started my investigation on the video amp tube at 12AU7. There's only one cap on it, a .047. Replaced that, checked the resistors around it. Didn't see any major problems. So I got out my voltmeter and started checking voltages, and they are way off. So the most negative voltage in this set should be this minus 85 volts. It's over minus 200. Conversely, the plus 225 is only about 100. So the voltages are shifted. Overall, the voltage is about right, but it's shifted way over towards the negative. Now, how are those voltages established? Well, say this is not your standard full wave rectifier set. The center tap on the secondary doesn't go to ground. It goes to that minus 85 volt rail. And there are a bunch of big old power resistors in here to develop these various taps. Minus 85, minus 17.5, minus 14, minus 3.5, plus 115, plus 225. That's what's in here. So let's check this out. I'm thinking there's one of two possibilities. One, some of these resistors are open, which is a relatively common problem. The other is things are just really whacked out still. Bunch of paper caps could be really altering the bias on tubes so that they're conducting too much and throwing the load off on the power supply. See, when you have voltage dividers like that, there's no voltage regulation in these sets. They chose power resistor values, bleeder networks to divide the voltage, but it also relies on a load being in a certain range. And if the load is really excessive, maybe on the positive side, and too light on the negative side, it's shifting the whole thing over. Plus, I figured you guys want to see what's in here anyways. So there you go. That guy and that guy. There's one thing I noticed. I've had this running. I haven't had it running too long, but this isn't really getting warm. You think with this monstrous thing here, it gets crazy hot. It doesn't get that hot. Remember, power resistors back then couldn't take all that much. A power resistor this size, in modern power resistors, that'd be a 100-watt resistor. This is probably a 25. And we got a Candome bed down there, which are also notorious for being pretty crappy. The tricky part with all this is figuring out what is what on the schematic. So I think we have one. I don't think this is tapped. This is one resistor. This is another resistor. But I believe this one is tapped. Shuts off. So let's look at him poking around. So let's start out checking this guy. We got minus 2.8 mega ohms. And see, that's what can happen when you still have a little bit of charge in the set. You don't really throw off your meter unless you disconnect everything. You got 11 meg on that side. It's not a good sign because there should only be a couple hundred ohms. And regardless of any cap's still holding a charge, a low resistance value would bleed away that charge, and this would not have a crazy value like that. So I think that was open. Shit, this one's not measuring too well either. But I'm getting infinite. Nuts. I say nuts because, yeah, you can replace these. You can get. I've done it before. They're expensive. I might have to order something. Oh wow, that is dead on 10K. Is there supposed to be a 10K in there? No. 8200. Let's continue. So this is ground. So this, try to get our bearings here. It's got to be this point, which means this is our 154. So we should have 8200, 35 ohms, and 100 ohms. 1, 2, 3 sections. So this side should be the 8500, because I'm guessing the farther apart the terminals are, the higher the resistance is going to be. And yeah, about 9K. And then this should be pretty small. 370. I think it's supposed to be 35. So that's not looking too good. And then we get 10K here, which is also not right at all. Crap. Is every section except this one bad? Jeez. Alright, so what can we do? Well, I'm going to disconnect some of these wires to completely isolate it, so we make absolutely certain. I'll see what we have on hand. These are oddball values. So this big guy, 1,125 ohms and 610. Modern values, you can get a 1K. 25 watt resistor would be fine, but not quite enough. So you could add 100 ohm resistor in series with it. 610, you get a 560 or a 680. Or if you really want to spend some money, you can get adjustable power resistors. Alright, so let's see what we have on hand. So here's a 1500 ohm 20 watt. Now another thing you can do. So I got 1500 ohm. We want 1125, right? Put another resistor in parallel with this. Maybe a 10K, something like that. And it could be much smaller wattage because this will be the brunt of it. Just to pull it down a little bit. I could clip these wires off, reuse this mounting, and that would be one of the sections right there. So notice how much smaller they are. It's a 20 watt. As I said, if you really want to spend some money, you can get one of these beauties. There's papers there for your protection. So if you take this out, you can loosen up the screw, and there's a There's a section, there's no enamel. This is resistance wire around a ceramic cord, and they put vitreous enamel over it. On these adjustable ones, there's a section where all the wire is exposed. You loosen up this screw, and it's got a little dimple in there that rides on that wire. You can slide it along and adjust the value. Now we don't need a center tap, so you could just attach these two outer ones together and make yourself a variable resistor. As I say, these ain't cheap. These are 1500 ohm, 25 watt. I probably bought it for one of these sets so I could tweak this and get exactly 1125. Price, it's been a while since I looked at these, but something like a fixed power resistor, like one of these, maybe say it's $10 and this is 20, something like that. But generally speaking, these cost 2.5 times what a fixed one cost. So I got a couple 1500. This is 1,000. 3K. Another 1,000. So I'm not seeing too much in my stash. That'd be closer to 600. I'll keep looking. Yeah, my selection's a little lean. So I'll order up some stuff, but maybe what we can do for now is take the 1500 or a 1K and take this adjustable and mount them in here. This one is much more difficult to deal with. It's can dome, so there's resistance in here, and it's inside a metal box that's riveted this. We can drill out the rivets, we can get this out, but mounting a new one in here. I guess I could use chassis mount resistors, these guys. Drill some holes in that and mount them like that. That's probably the best way to go. I gotta see if they list the wattage for these anywhere. Otherwise, well, actually, that's fairly easy to figure out, isn't it? Yeah, I'll do a little math here. So we got 150 on one side, 225 on the other, 1125 ohms. What is it? V squared over R is power. So I'll grab a calculator and see what that actually is wattage-wise. Alright, so 225 minus 150. So it's got 75 volts across it. So it's 75 times 75. And then we divide that by 1125. So it's only a 5-watt resistor. And safety margin, at least double it, so say 10 watt. So saying these look imposing, and they're in this box. You think it's radiating hundreds of watts. No, not really. These old parts just couldn't take the heat. Yeah, so I can go, let's see, what's this? This is the 20 watt resistor. That's 4 times the wattage. This would work just fine. Just a little bit low, but you know what, for now, to power this thing up, this is close. Within, 10% or so, we can go with this. I temporarily disconnected some wires so I could isolate the sections. These two are definitely open, and that larger section down there is open. These two sections seem to be okay. So what I did is, I just tacked power resistors in parallel with the open sections. So I just used the two 1Ks I had on hand. Yeah, it should be 620 and 1125, but just it's better than it being open. And I did have the exact 8200 value for that guy. The set is on. Yeah, they're getting a little toasty. And let's see. Hey. That's the brightness control. So, it'd be much more pleasant to work on now. Still no hiss out of the speaker though. That surprises me, but that's fantastic. So, alrighty. So now we know what we need to do. We got to come up with a better solution for those power resistors. And keeping on with the recap. We got 2 more paper caps to do. I figure I'll go after those 2 guys next. Alright, so we have a raster. I've started replacing a few more caps. No significant difference. I have placed up an order for some replacement power resistors. Now, we haven't heard a peep out of that speaker. I suspect I know why. I've been dreading checking this because I think we're going to find we have an open output transformer, which means I'm going to have to track one down. And that is this guy right here. Usually it's the primary that goes up on these. Secondary, far fewer turns, heavier gauge wire. The primary is the high impedance side. A lot of turns, fine wire. And that's also going to the power supply. We know we've got all sorts of trouble in this power supply. So, anyways. So this transformer, we got 2 wires coming out of it. One's going right to this tube 6K6. Other wire is going also over there. So let's see, it's going to 2 pins on this tube. These wires are also crunchy. That's sure looking open there. Continuity and no continuity. Output side, sure. Of course, it's in parallel with the field coil or voice coil rather on the speaker. So to really check that, you should disconnect the speaker from that transformer. But the primary, yeah, it's not looking good. So what do we replace it with? Well, if this was screwed in, in the interest of getting this done, I might be willing to take one out of one of my sets and pop it in here, but it's riveted, so you gotta be drilled out. I'm not crazy about doing that. I have the original service info. All it gives you is the RCA part number. No specs, nothing. I don't have a manual to look up what those specs are, if they were ever even published. What I really need is a cross-reference guide, or the Sam's photo fact. Now, somewhere, hopefully here somewhere, I haven't seen it in a long time, I have a great cross-reference manual where you can look up the brand and the part number, and it'll give you the Merit and the Thordarson universal replacement parts. So, yeah, an OEM part is nice to get, but there were a number of manufacturers, Stancor, Merit, Thordarson, Chicago Transformer Company, that made generic replacement parts, just like with cars today. But you need that cross-reference guide. Or, if you're lucky and you have the Sam's photo fact, they would often list 2 or 3 alternatives. I don't have the Sam's photo fact for this, I don't think. And it's not published online that I can find. However, I do have a secret weapon in Shango, and he, I believe, has access to the whole Sam's Photo Fact library, and he has offered to look it up for me after I asked him nicely. So, while I wait for that, move on to other things. I'm going to take a quick look around here for my cross-reference manual again. Now, the audio output on this, it's a 6K6 single-ended Class A output. Speakers probably 3 watts. I could find something. Either a new old stock, or something pulled out of another set, or a new Hammond universal single-ended output transformer. It's nothing exotic, and no, I'm not going to rewind it. That would be crazy expensive and take forever. It's not that it's not that special. But it means until we do something, we don't have any sound. But yeah, that's what I was worried it would be. So while I'm waiting to hear back or figure out what I can replace it with, I'm going to continue on with the recap. I've replaced a few more of the paper caps. I'll keep on with that, and I have 2 more electrolytics to do. Everything well, I kind of just look at the RCA part number because that gets me nowhere. RCA is long gone. if you're really lucky, maybe somebody would be selling one on eBay with the part number, but no, there's nothing out there. You really need that cross-reference. Well, you can't always get what you want, but I got what I needed. I couldn't find my nice little one with the Merit and Thor Arson, but I found a stand core from '54, and so this is what you need when it lists by brand and model. So if we flip through here, RCA 721 TS down here, and then they list power choke, flyback vertical output, vertical block oscillator, audio. So if we go from the top down, the audio column across to the chassis, we got A3823. That's what I need in terms of stand core. Now there was mergers over the years of probably eventually they all merged into one company, so I think there are stand core to Thor Arson guides as well. But that's something. That's something. A3823. I can look that up. Now, from what I do know about these new old stock audio output transformers, because of the autophiles, because of the tube amp rebuilders and hobbyists and enthusiasts, they can get pretty steep. So, see what I can find. I also just got this from Shango. So we want a 7177.6. So 24S61. That's I forget who, but that's one of the other replacement makers. So options are good. Options are good. I'll see if we can find either one of these online somewhere, or at least the specs for them. I did some quick searching around online, and somebody got a great deal on eBay back in March. They got one for $10, like new in the box. But otherwise, we're talking $50, $60 for new old stock or used. And yeah, Hammond does make the 125 series, single-ended. You can get an 8-watt universal replacement. They're $65 plus shipping. So it's awesome that you can get them, but I kind of knew that's what they cost, a little bit higher than last time I looked. So if you've been watching, I have my beginner series on early black and white TVs where we did an Admiral, and that was a case of everything went right. Just basic recap and a little tinkering. This is the opposite end of the spectrum, where we have you replace the picture tube, expensive-ish transformer. We've got to rebuild this power resistor assembly here. Got the transformer out, and I can't find the brake. It's down in there somewhere. But I also verified how dinky this thing is. I'm thinking it's maybe a 3-watt, 5 at best. So I went hunting around and I found this guy. And that's exactly the same dimensions. This came out of a Motorola. I think a 7-inch electrostatic set. And we're going to try using it. So those use a 25L6 output tube and a 6K6. They're both beam power output tubes. I believe, if anything, the 25L6 is more powerful than the 6K6. So we'll give this a try. I also have a Philco parts chassis, but that transformer is a little too big. So it's not rocket science. It's just a low fidelity audio output transformer. So I drilled out the rivets. I got to clean out the stumps of them in there, and we'll try wiring it in. And while I'm doing that, I'll recap the audio output circuitry there too. It'd be nice to at least hear some hiss out of this speaker. Make me feel a little bit more confident that this set is going to live again. Alright, let's give this a try. Dug up a transformer. It looks to be exactly the same size. And just clip it in with some leads. Yeah. And this is going to the grid of the audio output tube. It's like we're in business. Obviously we have a lot of home. We still have a lot of recapping and checking to do. We know we got some weak tubes in there. Alright. Excellent. So now that I'm basically finished working that area, and these mounting holes line up exactly, I'm going to go ahead and mount that and wire it in more securely. Oh, this project is turning out to be more fun than I anticipated, that is for sure.